Suppose this is your slab panel. Okay. So this is our assumption to distribute the load. Now so for this thing, your diagram will look like something like this. Okay. So you have to calculate this height, and this distance you know. This is same as this one. Similarly, this is same as this one. Okay. Only height is unknown here. What I told you is you find out this height. This you can calculate, right? Consider this angle is 45 degree, then you know this. So if you know this and if you know the angle, you can easily calculate this height. So whatever is this height, that multiplied by load intensity. Load intensity means suppose you have 3.5 kN per meter square as flow load. That 3.5 multiplied by let's say this is H1. So 3.5 multiplied by this H1 will give you this. Will that much simple? Okay, no complication. Similarly, if you calculate for this also, same formula. When you calculate for this, directly you get H1. But the formula will remain same, 3.5 into H1. Okay, this is applicable for all the forces. If you want to know the background behind this, so that is the total load of this load diagram should be equal to the total load available here. So you just equate it, finally you get this. Okay, so I think this load definition you can complete.
Yes.
So you can define the dead load separately. Dead load means not for beams and columns. That will be already automatically considered as an object because you have model load. But like slabs, sometimes you model slab using cell element, sometimes you do not. Okay, when you do not model the slab, that time you have to manually apply the load for that slab. So that time you can create the load case for dead load, then apply the slab load there, and live load separately. Now in dead load you have multiple load types like floor finishing, bend tiles, like this some other kind of load may be there. So you have the freedom either you can assign those in a single load type or you create separate load case for each of those. Okay. Then I think in the last class we have also completed the design, right? Reinforcement detailing, all those is shown. Failure of, means after designing how after checking beam reinforcement, column reinforcement, all those we have shown.
No, sir.
No. Then in failure what I have
Some sections are being failed after applying the
reinforcement I haven't shown. Okay. discuss response spectrum analysis, model shapes, then how to check refreshing, all those things. See, in my model, I did not apply all the load tests. Okay, so result what I will be getting will be different from what you are getting. Okay, you apply all the load types. Do not compare with my result. So also you know after analysis what are the different checks you have to make before proceeding to design, right? Also know this or any doubt? There are some coded provision that you have to satisfy. So I'm asking whether you know this all these things or not. Ganesh, you know? No? Okay. One thing is to check the drift ratio. Then another thing is model analysis parameters, like what is the mass participation factors, whether your fundamental mode is translational or rotational. Then okay, let us discuss one thing. The first thing you check is the model response parameters. So you have to go to display, then this option, and here you can choose the structure. Base tier correction you have shown?
Yes.
Okay, that you know. Okay. So at this stage, just assume that base tier correction is done. Okay. So after that you check this model response parameters. And here you choose this option. Now here you see this is your first mode and this is the period for first mode, which is the 0.37 seconds, and the direction is y. Okay. By looking at these values, we will understand which direction your mode is acting. Okay. Where the participation factor is given maximum, that will be your direction. Okay. So now the first mode is acting along y with the mass participation of 82%. Okay. The criteria given in code is the summation of first three modes in a particular direction, not first three sequentially here. Okay. Now suppose I am checking for y, so you have to consider the three modes in y directions, then add them up, get the total. That total should be more than 65. Now here if you compare, first mode itself is giving you 82, which means that criteria is already satisfied. Then another criteria is the sum of all the modes in a particular direction will have to give you more than 90%. Okay, so you have to check how many modes you have considered and the sum of all how much you are getting. Now in this model I have considered total 45 modes. Okay, and if you check the sum, see here sum of y means I am checking in y direction and the sum is 1 means 100%. So using 45 modes and achieving 100% mass participation. Okay, so this is better than what usually given as the minimum criteria in the code, which is 90%. Okay, but in this model, what happens? This is just a simple configuration, is very simple. That's why it is possible to attain this 100%. But in case of real structure, you will see architectural requirement is very complex. Okay, so in that case, many of the times what happens, even satisfying this 65% becomes difficult. Okay, so when you go to actual design, work on some actual project, you will understand how difficult it is to satisfy all those criteria. That's why code is given some minimum criteria so that you can at least satisfy those things. Okay. So So these are the conditions we have to check here, and one more thing is this one. This is the first mode period, and this is the second mode. Second mode means first mode period of two directions. One is for x, another one is for y, and both should be separated by at least 10% difference. Okay, it means you take 3.37 seconds, calculate 90% of that, and the period of other direction should be less than that. How much you are getting?
3.03.
3.0 means that condition is not satisfied. So the reason is our structure is little bit square in shape. So in both the directions we have similar kind of participation. Okay, so that's why period is very much closer. Now why put this one is to prevent the torsional behavior. Okay, you make a rectangular structure, it will have less tendency to have the torsional behavior compared to a square structure. Okay, so to prevent those torsional behavior, that criteria is given.
This is the difference between the two modes, between the two directions.
Fundamental mode of two directions.
Two directions. So 1 and 2 is the equal.
See, this first mode is representing y direction, second mode is representing x direction. Okay, so fundamental period of two directions should be considered. Okay, so now in this building, that criteria is not satisfied. Okay, but this is not a very much serious condition you have to satisfy. You can ignore this one if you know what will be the implication and how to overcome those implications. Okay, so just remember this one.
Variation 10% कम होना चाहिए.
So these are the things you have to check your model response. Then
कम होना चाहिए.
go to display and click on this storage response
इसके आसपास
clause.
होना चाहिए.
Ganesh, you have to then check for break ratio. Click on this maximum storage break
ज़्यादा यहाँ.
and choose the arbitrary force. Response spectrum load case.
We should consider the load without.
Yeah, without factor. Let me check whether I have that factor or not. Factor is not applied, so you can check with this. It means base shear correction is not done here. Okay, because if I apply the base shear correction, this factor will be changed. I have to manage with some factor.
Last we did that load cycle product without any factor.
Okay, load case I created separately. Let me check. I don't know, it's not there. You can create. Just make all those factors as 1 instead of 1.2. Make all these as 1. Okay, and do not apply any base shear correction to RTO force. Okay. Then let me create one. Just make all this 1. And this is 1, and this you have to remove. Means for each direction separately you have to check. Okay. Here you can give it break check. Now you can choose that load case here break check RQX. Okay. So the peak drift is 0.002. How much is the limit as per code?
0.04.
0.004. So that condition is also satisfied. Okay. Similarly, you can check for other directions. So these are the things you have to check before moving to the design. Okay. So once all those conditions are satisfied, then you can go for designing. And when you are going for designing, first you have to check whether code is proper or not. Here you need to use this IS 4562000, that is fine. Then number of interaction curves is 24. This is related to that angle what we have discussed. Okay. So if you divide 360 by 24, you will see at what angle those interaction curves are plotted here. Maybe 15 degree, and I'm not sure, just check. Okay. Then number of interaction points. It means how many axial force levels considered. Then consider minimum eccentricity, yes. Additional movement, yes. Speed delta, you can make it, yes. And DC capacity ratio, yes. And these are the factors of steel and concrete. And some default properties, you can leave it as it is. And pattern life load factor, I don't know what it does. Utilization factor is 1, means whatever force you have applied, whether the 100% will be considered for design or not. Okay. In load case, we apply some factor 1.5, 1.2. That is part of the load factor given in code. But separately, the software also asks this one, whether the load whatever you have applied should be considered 100% for design or not. Okay. Maybe some code will have this criteria. We do not have this criteria in our code. Okay. So you just keep it 1. Then you also have to consider this whatever combinations you have created. I do not have so many combinations, whatever is given in code. You will first create all those combinations, then those will be appearing in this box. You have to select those, then shift it to the other box. Okay. Now whatever is available in this box, this will be considered for the design. Okay. Before designing, you have to do this. But see, this drift check combination need not be considered for design, because this was just for checking the drift. But it will not create any difference if you choose this also. It will have the force inside this will be lesser than the other combination, because here you do not apply any factors. Okay. Then just click on this start design. Now see, it is giving you the reinforcement in beams and columns, and before checking the reinforcement, you just check whether you have any failure or not. So click on this and click on this option, identify all failures. Okay, apply. Now if you click on 3D, it will give you the location where it is failing. See, so many places are failing. Okay, and under what condition it is failing is also shown. For example, this is failing in PMM. Okay, means the interaction curve is not sufficient to take the load whatever is coming to the. It means the size is not sufficient. Okay. Similarly, at some location it is given as B, means this member is failing in shear. B means shear. Okay, and pink means it is past.
Past particularly corresponding to capacity और डिमांड की वजह से डिफाइन होता है.
या
तो कि इसकी कैपेसिटी से बाहर हो रहा है,
इसके
इनका जो रेट और कुछ सिस्टम की ग्रीन भी आ जाता है.
ग्रीन का मतलब
मतलब यहाँ पे नहीं आ रहा है.
अच्छा, कुछ जगह पे आता है. That means see green, then yellow, then pink. Okay, green means it is very much over designed. Okay. So you have basically like very huge section compared to minimum force requirement. Okay. Then yellow will be like intermediate, and pink will be like optimal, little bit optimal. You did not design it as a over designed member. So when you see pin, you just think that it is well designed within a reasonable estimate of requirement rate.
बिना था तो उसको टमाटर की फॉर्मेट
Within a certain you can reduce the size.
मिला के
Now here see you have only pink and this one red. That means it is failing. So you have to check the condition under what condition it is failing, and accordingly you have to decide what to do next. For example, now I have two conditions of failure. One is PMM failure and the one is shear failure. So you need to know how to overcome each of these failure types. Okay, now if I ask how to overcome, what should we do to prevent this shear failure?
increase the depth of slab.
Huh?
Increase the depth of slab.
No, this is not failure of slab. This is the failure of beam.
Beam.
shear reinforcement does not
Shear.
Let me show you in plan view. See. What should be done to overcome the shear failure problem?
So reduce the spacing of tie bars, but etabs how will you do it?
Increase the grade of concrete, okay. Anything else? Spacing.
reduce the
Spacing. Okay. Anything else? Depth of beam. Will it work?
no sir shear deformation ज़्यादा होगा ना डेप्थ अगर इंक्रीज करेंगे तो shear deformation फिर
Shear deformation will be increased. Okay. So increasing the depth of beam or depth of angle, it will not give you the solution.
Sir, in etabs we cannot vary the spacing of tie bars or beams.
See, the problem here is not created by the spacing of tires. It's created by the how much force is coming and how much section is given. Because we did not specify the spacing. Okay. The software what it does, it takes the force, then try to design the member according to code requirement, but it is not able to satisfy the shear criteria. Okay.
so we
The
can
software considers whatever spacing criteria is given, it considers within the acceptable limit, but still it is
तो
not
साइज तो नहीं हो सकता
able to satisfy the condition. Means the problem is not with the spacing of tires.
The longitudinal bars will increase the longitudinal bars, number of longitudinal bars.
You can try many things. You can increase member sizes. See, it is not only like if you are increasing member sizes, member will fail in shear. Okay, because there is another concept of load distribution. Okay, so if you are increasing the member sizes at multiple locations, it may so happen that the force distribution pattern may change. Okay, so you can try. You can increase the member sizes. Then you can increase the span, because one of the main things which affects the shear failure is the span. Okay, if you make the span longer, so shear failure problem will be minimized. That time it will fail under flexure. So when you have flexural failure problem, it is very easy to overcome that. Just increase the reinforcement and even increase the size also. But here in case of shear, you do not have that freedom. If you are increasing size, it will increase the problem instead of reducing. Okay, so you have to keep on doing some trials to minimize this shear failure problem. Then PMM interaction, it's directly related to size. Your size is not sufficient, just increase it. Okay, means finally the capacity is not sufficient. That is the meaning of PMM interaction. So now we can revise the design since this is failing. You can go to increase the member sizes. Let's say instead of 400 to 400, And again, you can choose multiple member sizes at multiple locations. Okay. Now in this model I am using only one size, but since the upper storage we have seen it was not failing, so you can put the same size there, and wherever it was failing you just select those members and define some higher sizes for them. Okay. So instead of maybe I keep this as it is, I create a copy of this. So let's say 500 by 500. Okay, so now this is just a trial process. We will the member sizes then check maybe whether design is satisfied or not. Okay, so we'll stop here, and from the next class we'll move to the nonlinear analysis. First we will start with pushover analysis, then we'll go to time. Okay, so till then we just complete this design, and in the last class also I told, because I have not modeled it fully, load definitions are not fully modeled, so you just complete it and give me one model so that we can use this for further whatever analysis we will be doing. Okay, so it's up to you, because if you want some realistic estimate, so you need to give me a real model. Otherwise, I can continue with this model. This is a half prepared model, so the result what you will be getting is not going to be realistic. Okay, so complete, at least assign all the loads, possible loads, then give me the design. It is not going to take much time. So you complete the load definitions fully and give me, including the load combinations. There are around 49 combinations as per IS 189.3. Apply all those 49 combinations and apply all the different loads and give me that. Okay. So from the next class we will continue with that model if you are giving me. Fine. model I have shown the slab model explicitly, and I told you should not use this for nonlinear analysis. You know the reason, right? So use that model where slab is not there.